Hi, everyone. This is Plasma Call number 11. Today's July 4th when we're recording this, so maybe we'll keep it a little bit shorter this time or run long. It's all good. So I guess, as usual, we'll start off with updates, if there's any updates, and then dive into various topics.
Sounds good.
Well, yeah, since Dan wasn't here the last time, maybe he should talk first about the plasma debit.
Sure, yeah, I'm happy to. But also, I think Georgios would love to hear about the Loom release with Plasma Cache. I think that was super exciting.
Yes,
so that's definitely something else we can discuss. Yeah.
Yeah.
And yeah, go ahead.
On Friday, we open sourced our Plasma Cache implementation. It does we do deposits, exits as described in the original spec. We had some discussion, short discussion with Dan that perhaps some challenges can be removed or, like merged, I don't know, like basically like doing the same stuff with less contract functions and less data. And I still haven't looked into that yet, but it should be possible. The master branch right now in my repo, it does ERC 721 because you don't really need to do splits and everything, so it made more sense to just go for that first. But right now I have an open pull request which does also ERC 20 and Ether, because the change is not really big because the plasma chain does not really care since all tokens are equal. And yeah, it works, I believe. Please, if you want, please take a look at the code. We have tests for many scenarios, for invalid exits, the operator withholding or submitting invalid blocks, colluding with other users to steal coins, and it looks like the currently implemented challenges, they cover everything. And but we do not cover exit griefing by the operator. So if they withhold an in-flight transaction and you lose your bond because you try to exit, and we did some short discussion on that last time.
Oh, so you're running this on Ropsten as a result? Is that the thinking?
No, I haven't. It's not deployed on Ropsten.
Oh, okay, cool. Just testing out local machines type of stuff.
Yeah.
Cool stuff. Yeah.
And good. We have a local, so for benchmarking and everything, we have used a part of the Omise Go repository. So we open a Flask server, and we use the Plasma chain as the Plasma chain is just a Python app that you do all the testing on it.
Cool.
Testing of the Plasma chain.
Yeah, but, and I saw it was, I think, GPL3, right?
Yeah.
Very cool.
And yeah, you have any? That's pretty much it. If you have any questions that you would want me to clarify, let me know. Yeah.
Okay, and maybe post a link that way people can take a look.
Right. Yeah. Of course.
Repo and anyone else updating, I guess, post a link to your repos as well if you want.
And I also made an ETH research post like describing the procedure, like what are our what do you call it? What presumptions we're making and all that. And it's quite a bit detailed, I think. So yeah, you can take a look and we can have a discussion on that there. And yeah, for future work, basically what we want is like to explore. Basically, we want to start doing XT and splits, because it would be really nicer if we could do more interesting stuff than just having a 5 Ether coin, for example, and like passing it around, like one input, one output. Yeah. And also maybe atomic swaps, like between two coins. So instead of like just doing I sent coin A to B, A sends coin to B, it could be like say A trades two coins with B, which would be much nicer. And especially in collectibles use case would be also nice. You trade your card for another card. Yeah, that's more or less it.
Yeah, definitely. That sounds awesome. And yeah, you posted a link for people to take a look. Cool.
And we also implement a form for doing like more concrete, more compact proofs for Merkle tree, because we use a sparse Merkle tree. All credit goes to the Walk team who made a recent post with probabilistic payments and all that. I do not remember exactly the name. But basically they describe the scheme where if we have a sparse Merkle tree, you can just add a bitmap, a bit field in the beginning, and if it's 0, you take the default hash, and you can actually have very, very smaller proofs. Yeah, but still, like in the long term, you will still be bound, like you will still have an upper bound. So the problem persists that we have linearly increasing proofs, and doing Plasma XT, I hope, would help with that. And for that, I was looking into how I found a thread basically that says checkpointing the UTXO set with Merkle trees. Are you guys aware of that?
What document?
So using Merkle tree to checkpoint a UTXO set. So I was thinking that perhaps, I don't know, Dan mentioned this to me in a private message. He said, Joseph, you mentioned it.
Yeah.
TXO commitments.
Right, but I think specifically the Merkle tree structure. So Joseph, you mentioned that in the call like a month and a half ago, maybe, that that you and JJ were thinking of Merkle tree.
Yeah. We might actually be talking about that this Friday at the Stanford new blockchain lab that Dan Vermeer has.
Right, but how does the Merkle tree provide any advantage compared to a sparse Merkle tree? Since in the sparse Merkle tree,
it's basically a sparse Merkle tree. Sorry,
yes, it's ordered because the sparse Merkle tree is still ordered by the.
Yep. Yeah. Same thing. Yeah, same thing. Yeah.
Okay. I imagine that it would be useful in Plasma MVP, for example, because you don't have like a clear way to sort.
Yeah. It's going to be a generic library, but the difference is that it's just designed to be high performance on the disk level.
Okay.
Yeah.
Yeah, that's more or less my input.
Cool. That sounds awesome.
Cool. So yeah, I mean, I think we chatted a little about this out of band, but I think you'd mentioned you were looking at doing atomic transactions, but I think something we'd found has been sort of difficult is trying to figure out how to do a limbo exit safe design that allows atomic. So there's ways. So like Kelvin and others and Ben and others have sort of ideas for limbo exits in both MVP and cache. But if you try to do limbo exits in cache with atomic transactions, it gets difficult.
Mm-hmm.
So I'm not sure. Yeah, certainly if you think about this, like, because it's sort of hard to do something like an exchange without having atomic transactions. So I'd definitely be curious if you run across that stumbling block to try to add multi.
I will try looking into that, because for the trading card game, it really makes sense because you want to do it in one step. And also over the weekend, I had a small discussion with Ronji that we could perhaps do, and I think he posted it on the HackMD also, for how we could do payment channels on Plasma with, if Plasma allows multisig. So we could also talk about that, perhaps.
Cool, yeah. So I think we had a couple calls ago. I think there was like some research. I think what was it? Was it David that you talked to? You were doing research on this specific topic.
What topic?
How to do state channels on top of Plasma.
I don't think so.
Oh, okay, never mind.
Yeah.
Someone was doing some research about this. I think there was an ETH research commentary, but there's not been too much looking into this. There is a post on this, and I guess we could talk about this here because it's sort of on our agenda.
Yeah, I sent it.
Oh, yeah, you already sent it, yeah. So do you want to go over this, or should I?
Oh, yeah, I can talk about this.
Yeah.
Sure. The way I think about it, there's actually two distinct ways to combine channels and Plasma. The first that was kind of originally put in the Plasma white paper is where you have payment or state channels that settle on Plasma, and that is super important, and I am trying to work through that. But there's a slightly different version with different trade-offs where you build channels that settle on Ethereum, and you build channels and you build a Plasma Cash network that settles on Ethereum, and then you kind of link them two together. And the way you link them together is you allow the Plasma Cash chain to have UTXOs that's controlled by multisig. So for those UTXOs, you need 2 signatures to spend them. For example, you need 2 signatures to withdraw them. And you basically have the same tech. You basically are able to use those things to fund channels on Ethereum. So if you have a state channel on Ethereum with someone else and you want to use a Plasma Cash UTXO to fund it, you just you basically want to end up in a state where you have a Plasma Cash UTXO that has the same owner as the owners on the state channel. And all the owners of the Plasma Cash UTXO also need copies of the exit transaction that exited into the state channel. So this basically gets you, for example, a way to split UTXOs in Plasma Cash. If you want to split a UTXO with someone else, you can just set up the split in the channel on Ethereum.
Yep, and I think also this we talked a little about this. This is kind of a generalization also of Plasma Debit, which is where Plasma Debit is like a state channel just that with respect to a particular coin that is just between the current owner of that coin and the operator. But you could generalize that to have a coin that is partially owned by Alice and partially owned by Bob, and they can update their respective shares of that coin, and it's treated very much like a state channel. It can even be done in between Plasma blocks. And all you need the Plasma blocks for is to actually transfer that, to change that multisig, basically to transfer the ownership of that channel from one party or one set of parties to another one, or to some other set of parties. So I think that it ends up being sort of like a very powerful combination there. And I think probably, and would you agree that we're sort of working toward the same things on that? That they're sort of based in the same direction?
Yeah, I think it actually ends up sharing a lot of the features and disadvantages of Plasma Cash, but like it also achieves the extensions that were described, right? So I can talk a bit about the from a features point of view. So Dan is like as Dan said before, what this also gets you is instant finality, where like you can change the balance, you can update the balance in like a few milliseconds. And one thing that I wasn't completely clear in that post is that there's this property that Plasma has that pure state channel networks don't really have. And I don't think there's a good name for it, but it's the property where anyone can join the network anyone can receive a payment without creating, without any Ethereum, like opening a channel or anything like that. And you can kind of get this in the state channels and Plasma Cash combination by making the Plasma Cash contract aware of be able to send things to like deterministically computed addresses. So this is described somewhat in L4's latest paper, but like a deterministic address is one which only depends on the code. So you kind of you compute what the code of a multisig between two people would be, and you don't have to create a multisig, but you can authorize a withdrawal to that address. So that lets you join the network without creating an Ethereum transaction, and you have to create an Ethereum transaction if your counterparty or the Plasma chain is unavailable.
Yeah, and that makes it so that like if you don't have to worry as much about like certain routing issues and things like that, if like you just create the transaction if that person doesn't have any funds there at all, right? Is the thinking long term?
Sorry, I don't really understand.
Oh, insofar as if the person doesn't even have an address, an output, and then you can just create one inside the Plasma Cash chain, or you don't know if they have an output or not. you can just create one optimistically and give them the proof kind of thing.
So if someone hasn't, like, you're trying to give it to a completely new person.
Yeah.
If you're trying,
you split the coin in a way, right? Is that the presumption?
Yeah.
So I think the way to describe this property, if you're looking for a name for it, is that it's a transferability of a channel, which normally a channel is like just between Alice and Bob, and there's no way for Alice to transfer her share in that channel to someone else. And with the Plasma cache mechanism, you're essentially notarizing every update in a way that allows it to be transferred to Alice's share to be transferred to Charlie, and Charlie can receive this proof with all the Merkle non-existence proof of history that shows that he's the only one with the valid history for it. So I think that that's it really does sort of fix, I think, a big sort of potential sort of downside of state channels. I agree that you have to do on-chain transactions to enter into them.
Okay, that's a big disadvantage of like pure channels.
Yeah. And one thing that you see when a lot of multi-party channel designs is that they require liveness. Is that you can't have 100 parties in a channel and then selectively add and remove people, because when you do state updates, you're probably going to need everyone to be live. So if one person goes down, they can halt the system in a 100 out of 100 channel, which is the principal complexity of the trade-off that state channels make. But what's nice is that this helps sort of the areas where state channels are weakest. But where Plasma is weakest, this construction helps it as well. So it's like sort of complementary in both directions, which is pretty fun. Right,
that's a great point, and like one thing you can that you do is that if there's features that's too hard to build on Plasma, you just build them on the channel instead. Like if you can't build atomic swaps, you build atomic swaps in the channel, and you can do your swapping there.
What's the are there any updates when it comes to state channels? I heard L4 is working on a lot of cool state channel research, and specifically around making things generic. I think if they can do that, that could be really fun. But I guess that's more like Jeff's wheelhouse, right?
Sorry?
Oh, I was just saying, are there any updates from like L4 when it comes to like their state channel research and stuff like that?
Oh yeah, we published a paper, like a big 54-page paper, and we're gonna publish some contracts soon. Trademark.
Oh, cool.
But yeah, but the link between the Plasma cache and the channels doesn't need to be that tightly coupled, I think.
Yeah. It can be relatively generic on that level, and a lot of the protocol designs and code, like it's directly replicable, which is pretty nice.
Sorry, can I just ask, is it two-way, the bridge between the state channel and Plasma that you're describing?
Two-way?
Like a two-way peg, kind of, Yeah. Yes? Okay.
Oh, the presumption is you can move stuff into the channel and back out?
That's right.
That's yeah. I think everything should definitely do that.
So let me just try to get this right. So who is the owner of that? Is it the multi-sig contract address that you counterfactually instantiated? Who's the owner of that Plasma cache coin?
Right. So the Plasma cache chain needs to have a notion of a multi-sig UTXO. So like when you do, like you have to modify the exit game to make that possible. So you just set the, like on the client side, you create a channel with Alice and Bob, and you also make the UTXO owned by Alice and Bob on the Plasma chain.
Right, okay.
Could we also make it require just one of the two signatures, perhaps? If we did.
Right, I don't think that is safe. So like the what you really want out of the UTXO is that you need two of two signatures in this case to transfer it, but both people already have like pre-signed authorizations from each other that do certain things. So like if your party is unavailable, you broadcast the transaction that exits the UTXO.
Mm-hmm.
And then with this, you just set some type of like sequence, and you know, if there's a prior state, then you can penalize. But if it's both agreed upon, then you're good to go. And there's an additional delay in the exit mechanism if it's one of these types. If it's not, then you don't need that type of delay.
No, actually. So that's the I think that's the difference I was getting to at the start. I think what you're describing is channels that settle on Plasma, but in this one, you don't need a nonce. You don't need a increasing nonce number to have like, yeah. So
really?
Yeah.
How?
What if
because you just do it root Plasma on that way. I see.
And if I try to exit a prior state from our channel, you can just challenge it, you mean?
Right. So you challenge on the channel. So like,
so you challenge a later state. But how would you keep track of what is the later state? I think that's the purpose of the nodes.
Right. Okay. So yeah, this is a good point to kind of go to draw the difference. So if Alice and Bob both have 5 ETH, and then Alice pays Bob twice, so the balance updates twice, we want the second balance to be valid. So what if Bob tries to withdraw? What happens is the withdrawal goes into the state channel. So the whole like giant lump of 10 ETH goes into the channel on Ethereum, and then from the Ethereum channel it then gets split. So you do the timeout like trumping thing in the state channel on Ethereum. So if Bob tries to attack, it will look like Bob withdraws to Ethereum, and then Bob broadcasts the stale state on Ethereum, and then
so you create the contract kind of thing after the fact kind of thing. Like you're not literally creating contract after the fact, but you're sort of doing something similar. You're submitting the state to the contract after the fact.
Yeah.
I see.
This would be like I imagine this being implemented as the Plasma contract actually deploying a new contract for every kind of dispute. Is that?
Yeah, sure. That could work. Yeah.
I'm kind of afraid that we might end up spending we're actually bound by the implementation of Ethereum regarding gas costs.
Yeah, that's definitely a concern, and that's the reason why I think like building channels that settle on Plasma will end up having better features than this.
But require more thinking.
Sorry.
But it has more things that need to be done.
Oh yeah, it's so tricky. Like I thought it would be easier, but
maybe Dan wanted to talk about Plasma Debit further.
Yeah, sure. I mean, and that's a pretty good area. Like I said, I think it's a very similar concept. But the basic idea, right? So I mean, the basic idea is that you can refactor. You could think of it partly as adding a feature to Plasma Cash, but another way to think of it is as refactoring sort of like a state channel or a state channel hub, and looking at. So what you do is you basically look at Plasma Cash as each coin in Plasma Cash being like a channel between the current coin owner and the operator of the channel of the Plasma Cash chain, and so. Every update to the balance, or every coin, instead of having a fixed balance at like 5 ETH, has a number that can go between 0 and 5 ETH, say, and any amount that's above that current number, and each transaction can update that number as well as updating the owner potentially of that coin. The amount that's higher than that number goes to the operator when the coin is withdrawn, and the amount that's less than it goes to the that amount goes to the to Alice, to the current owner of the coin. And it's sort of the fact that it's always with the operator is kind of for convenience, because the operator has to sign off on every transaction anyway, so this doesn't involve any additional signatures. And it sort of simplifies a lot of the things, because you can make assumptions about what the operator knows and has control over. It lets you actually do, it makes stuff like sort of these atomic transactions a lot simpler in this model.
Wait, so what does the operator do?
The operator, so if you're just looking at it on a single coin by coin basis, if you have a single coin that belongs currently to Alice 5 ETH, if Alice wants to pay the operator 1 ETH, she can do so by creating a transaction and signing a transaction that doesn't change the current owner of her coin, but reduces its balance to 4 ETH. And then the operator is the one who's going to receive the residual amount of that ETH of that coin. So the 1 ETH that's you know, so it's like, you can think of it now as she's reduced her balance on that. So it's kind of like just a state channel between her and the operator, or payment channel between her and the operator. So now when the coin is withdrawn, the operator will receive 1 ETH and Alice will receive 4 ETH. So in effect, Alice has just paid 1 ETH to the operator. And that doesn't have to be in sort of round amounts. That can be literally any amount. So it can be like 0.0035 ETH. And you can make payments back and forth between Alice and the operator in this single plasma cash coin. So, and then that way, again, it sort of resembles a state channel.
One hope.
And then the way you can, and then the way you can make an arbitrary payment to anyone on this is for Alice pays 1.5 ETH or whatever to the operator, and then the operator does the same kind of thing to pay 1.5 ETH to Bob in his coin, in a coin that Bob owns on the same plasma cash chain, but a different coin.
Doesn't this require the operator to be very well capitalized, though?
The operator, yes. So it does exactly. It's got all these. Essentially, it returns us to like these kind of overcapitalization requirements of Lightning, absolutely. But with a couple benefits. So one is that you can transfer channels from one party to another. So once if a coin, for example, is completely collateralized to the operator, like if the channel is exhausted on the other party's part, the operator can just transfer that coin over to some new owner, and now has a full channel with a new owner without a new transaction on chain, or only with the block header. So you don't have to do a full transaction to open a channel. And this means that this gets rid of that problem. It means that someone can join a plasma cash, can open up a channel essentially with the operator without an on-chain transaction. Just by someone transferring their channel to the owner. So yeah, so I'd imagine what would happen would be the operator would actually be like dramatically overcapitalized and have a lot of empty channels on their sort of just ready to be transferred to people who they want to open payment channels with.
Sorry, Dan.
Yep.
Is it correct for me to say that this arbitrary denomination, the only legitimate recipient of this denomination is the operator, no one else?
No, because the sort of first hop goes to the operator, but then you can have the operator make an equal arbitrary denomination payment to someone else. You see how you can pay to the operator an arbitrary denomination, but you can also receive from the operator an arbitrary denomination, right? By having the number, and if your coin is undercapitalized, if the current balance is 3 and the total balance in that coin is 5, you can receive payments anywhere between 0 and 2 ETH just by sort of moving that watermark up, right?
But
then how does people like keep track and then verify,
Verify what?
Like the total balance checks out?
It doesn't have to. So the only concern in a single coin is between the operator and that party. It's never going to go above like 5 ETH, which is the amount that was deposited into that coin. So it still has the plasma cash property that you can't be cheated by someone else withdrawing from a coin. The only parties that can be cheated in that coin are the operator, who of course knows what's in that coin, so they're able to challenge, and the current owner of that coin, who knows what's in that coin and is always able to do the same plasma cash challenge that they normally can. So the way that Alice makes a payment to Bob on an arbitrary denomination payment to Bob is that Alice makes a payment to the operator of that denomination, and the operator makes a payment to Bob of that denomination. So it's kind of like multi-hop payments in a payment channel network like Lightning.
I actually think this is more like an actual atomic swap rather than multi-hop payments, because essentially it's like making 2 payments from A to the operator, B to the operator, while the atomic swap and essentially this becomes A to B and B to A.
Yeah, absolutely. So you need the operator there to sort of route to provide the
exactly. So
but yes,
I think we get back to the same. That's my only concern, that if the operator is cooperative, we're cool.
Oh no, but if the operator is non-cooperative, so this is, you need to have a kind of transaction that's only.
How do we enforce the atomicity? Yeah.
Sorry, David, we say something?
Yeah.
Oh, I was just agreeing with you, I think, where if the operator's not cooperative, they can end the chain anyway.
Right, and the transaction, they won't be able to get one of these in without the other because the transaction's only valid in a given block if the other transaction's included in that block. So there needs to be an atomic multi-coin transaction for this to work.
So we need a rule that makes a transaction valid only if its sibling transaction is included.
That's in the same block. That's exactly right, and that's exactly
Okay.
right. Yes. So there's edge cases in this around limbo exits, obviously, but actually I think it's a little simpler than other limbo exits because you have the operator as one of the parties.
So the presumption is with an exit, you have a tag and then you provide the tag on both transactions on an exit or something like that.
On a challenge, I think it would be, but yeah.
The question I would have is, has there been any thought on, okay, and this may be extremely premature, what are the considerations, and if there's no answer right now, it should be fine. What are the considerations for if we switch to, let's say, the operator becomes a proof of stake network backed by coins, like bonded coins, and then at that point, some tokens rather, of let's say whatever token, you use the tokens to bond the proof of stake plasma on top of Ethereum. What is the concept of the operator?
That's a great point. I think there's my two answers would be one that I don't particularly I'm sort of skeptical of multi-operator plasma chains. I'm not sure it's necessary. And I think, it quickly sort of I think it will tend to add a lot of complexity without necessarily benefiting that much. So generally I'd say this mostly designed for a single operator. If you do want to have multiple operators, I think you can usually model those as a single DAO that serves as basically the single operator. And in that case, the governance mechanism for the chain should also allow these parties to make sure that another one isn't able to steal their money. But you're already sort of assuming that the operators have some mechanism to keep each other in check in this system. So I think you would have it as a DAO, and basically the DAO as a whole has to over collateralize this contract at this particular amount, basically. And yeah, they'd be responsible for watching these. So that's what I think.
One way that I think you could do it is you tag it to a specific entity within that set, and then basically when a block is made, let's say if you require 2/3 majority, you require 2/3 majority plus that individual signing off.
That's a good point, and that works. That's true. And another thing I should note is that this is like I said, it's kind of a special case where it's the operator is one of the parties. And you could just have it be any two parties and just require signatures from both of them. This adds a little complexity, again, partly around having to have two signatures, and also this sort of makes limbo exits harder because you don't have the operator as one of the parties involved. But I think it's so for that you absolutely could just require a signature on that transaction, which again a little less efficient from that particular operator. So yeah, a little less efficient, but I do agree generally also that having if you have that's actually a really good point. So if you have a majority rules set of operators, then you could prevent the majority from defrauding that minority's coins by saying you need to have a signature from that particular operator on that block.
But on the plasma contract, this really doesn't matter, because the plasma contract, all it cares is the whatever message sender authorized at this round. So this would all be totally coded from an implementation perspective. It would be totally external to the actual plasma contract.
I think it depends if you It depends if you That's my model where it's a DAO that's operating. It's basically acting as a plasma operator. But if you had some kind of consensus system within that plasma cash contract where it would check signatures from it took deposits and checked signatures from a set of them, then you still, I think that you still could do this by saying yes, that money can only be decremented in a block that was signed off on by that operator.
Cool.
And then the third thing that I want to point out is about that. Oh shoot, I had it a second ago. It'll come back to me.
Plasma credit?
What's that?
Plasma credit?
Oh god. Well, so that's another topic altogether. But it's just sort of a name for one idea. For
Eventually, we will go plasma bankrupt. I think that's the way things are going.
Yeah.
Oh my. But yeah, it's that I think that construction is definitely interesting, along with what Xuanji was working on as well. Like both of those, like that seems like multiple viable paths that seem to work well, and are relatively compact, both of them. You know, on a design and implementation and impact on basically what the contract looks like. And I think that's what's nice about both of those, especially Xuanji's is like separated out. But you know, I think Daniel's there's this you can create capital efficiencies in interesting ways. Yeah.
Also on plasma debit, I think it's interesting for some meta aspects. For example, I imagine that a coin that has a total cap of 20 Ether, it essentially, even if it's empty, if it's at 0 out of 20, it has better value than a 0 out of 5, because on channels it has more capacity from a channel perspective. So it would be
right.
So it would be very interesting, like how we would do like atomic multi-hop payments with multiple coins. Like you have two over-collateralized coins, and you could do like a 20 and a 5 Ether coin, and you could do like 25 or something like that.
Yeah, I mean, there's a liquidity premium on that coin, right? Yeah. So like someone might be willing to pay more than that coin.
Exactly.
That's really
and I imagine that we could also have like secondary markets on all this kind of thing. So if we had, for example, a secondary market for fast exits, in that sense, you could also have in the same contract manage the coins.
Right. And I think given that the operator is sort of they can sort of act as essentially a centralized party in this, because they own a stake in every coin, so they would be able, I think, to sort of facilitate that market.
Exactly.
Yeah.
Like an auction house set up by the operator. Yeah. That's how I see.
Right, and I think we talked about this in the context of like merging and splitting before. Oh, that was what I was going to say, is that you can implement this without any kind of special rules if you have merging and splitting of coins, arbitrary splitting of coins and merging of siblings. Which isn't particularly difficult, and we've talked about before. It sort of isn't particularly difficult theoretically. It's just like adding a couple extra. You can add extra decimal points onto a coin's ID, but with that, you can, by just sort of reallocating between two coins, you can effectively treat it. That's very similar to having sort of like just multiple owners of a particular coin that just own pieces of it.
But this works only for the siblings, I think.
Yes, but that's enough to do like essentially the same thing as plasma debit, where you're just basically merging and splitting two coins where one is owned by like the operator and its sibling is owned by Alice, and then one transaction merges those together into one and resplits them into like Alice owns a little more and the operator owns a little less. That's basically what it's like. But it doesn't have to be the operator; it can be like Bob if it's merging and splitting.
Cool.
Yeah.
Awesome. Yeah, I think like probably by like within a month or so, I feel like we can almost even like get some type of general overview of what the design spec encompasses. Not necessarily the spec itself, but like what that would encompass. Maybe like very, very soon. I feel like we've like fleshed out a lot of the thinking as of late. I think that's really cool, and we've all like,
I think it would also be useful
thinking about it together.
I think it would be useful to define some kind of standard also, like the plasma standard or something, because you have some kind of interface in order to define properly the rules. And also, I want to say that I wrote that in a blog post when we released the Plasma Cash paper, the code. I also believe that we're in turn for a new plasma paper. I believe so.
Yeah, I think so too.
We have a lot of good ideas and everything, and I want to say that we're very open to collaborating on.
We should all
better plasma constructions, or some other fancy academic name. I don't know.
I think we should all work together on that possibly, and I think that could be fun as like a late summer project for us all.
Exactly, where I believe that we could talk about like Plasma Classic, the original one. And then describe how we have MVP, Cash, and friends.
I think paper type stuff is a lot easier. I think definitely specification what I've noticed with specification is it's a lot easier to have specification work once there's multiple implementations. And then at that point, like you just do a little bit of porting and then, you know, the message formats and stuff like that and resolve it that way. Before that point, it's very prone to bike shedding. Is the issue when you have specs without examples to look at, is what I've noticed. But definitely scoping, definitely like, definitely when it comes to design decisions and stuff like that. I agree totally with Georgios. Yeah.
And yeah, Georgios, like I think you've really appreciated everything at Loom. Seems it's like a fantastic sort of work, sort of prototyping it and moving that ahead. So
we're on fire.
But yeah, I think there's a lot of great implementation work by like everyone here, and like one or two people aren't here, and I think that's yeah, it's one of those, you know, big group efforts. I think, you know, Ethereum's very you know, it's proving that, you know, you can try to cut corners sometimes, but like if you do it right and try to do it right, at least it'll be fun. Yeah, on that note, are there other topics to discuss?
Yeah, okay. Yeah, from my side, I can add that yesterday I posted the first very preliminary implementation of the more viable Plasma smart contract with
cool.
priority based in the youngest input to the transaction. It's not tested yet. I have broken all the tests I had before, the old tests for minimal viable Plasma. And so far, we'll just continue to work on it and continue to make a well-optimized client to verify a good number of transactions per second. Otherwise, Kostya wanted to could talk about what we see as a SNARK instruction for Plasma, for a balance-based Plasma, and I also linked the very interesting topic on S research about how you can make, how you can require from the operator on a new block the proof that the operator actually preceded all the deposits and all the withdrawals. It was a good idea. I think it should be the next step on working on the SNARK-based Plasma. So
or you could use an oracle.
Sorry?
Or you could use an oracle. You could use an oracle to ask people, like you have a party that you trust and you ask, have all the transactions been processed? And if there's withholding, the oracle says no.
I think it's in a different sense. For example, well, it's even while you can prove in a SNARK-based Plasma that your block is completely valid, so you've seen all the signatures, you properly updated the balances and everything. If you withhold and try to make the blocks which are not non-available, you cannot post. Well, you cannot post a new block if you don't actually prove that in this block you put all the deposit requests and all the withdrawal requests that people posted on the main smart contract. I think it's very preliminary. Well, the idea is great. I don't know if the implementation is possible. It looks pretty much possible, but I think will be non-trivial. So if you would like to have a look, I posted the links there. Otherwise, the second paper is Kostya's proposal for how you can construct the SNARK for balance-based Plasma. First, it would require some optimizations in a sense that standard hashes like the one used in Ethereum, the catch-up 256 are just too expensive in terms of constraints. So I think you can talk more about it.
Yeah, maybe you could like write up it and then maybe talk about it next time after we could take a look.
Yeah, I send a link.
Do you hear me now? No?
Hello?
Yeah.
Yeah.
We
Just, yeah.
Do you hear me? Okay. I did have some problems with sound, and if you want, I might give you an idea of our SNARK-based approach to Plasma transactions. We're investigating this problem for some time, and for now we do not touch some such problems as entering the plasma or exiting the plasma. And now we are working with the state, with the plasma state, where leaves contain only balances and nothing else. That's just the solution only for tests, but it is enough to test our SNARKs. And the idea is the following. Let's we have some transaction, a simple transaction. It has 3 public inputs: the spending address, from address, the destination address, to address, and the amount of money sent. And the idea is the following. We give two Merkle proofs for both addresses, for destination address and for from address. And then, and at a certain point, we prove that the parts of these Merkle proofs are in fact agree. They're the same on the common prefix for these 2 addresses. This was Alex Vlasov's proposal, this idea. And I think that though this check is not expensive, it requires only H constraints, where H is the head of the tree. I think that it is not at all necessary, because these additional checks they only make the collision based checks more expensive. But if somebody will be able to find collisions for our hash, to find another leaves that will give the same Merkle tree, I think that it will even possible for him to find two proofs with the same common prefix. So we give 2 proofs, 2 Merkle proofs embedded in SNARK. Then we give some constraints that enables us to check that they agree on their common prefix. And then we have constraints that check that the first leaf, which is associated with the spendable address, with the address from, have enough money to spend. Then we
just in case, Kostya, for a second, I think the full explainer is in the paper. So what would be the most interesting part? Have some thoughts about how we can, based on a post at Is Research about the linking the required plasma exits to the proofs. If you would have some time to check it and maybe have some ideas if it's worth trying to implement, would be great. Otherwise, what I wanted Kostya to explain as what are the chances to make real recursive SNARKs to aggregated transactions mainly? It was a topic of interest.
Okay. If we will be able to make a SNARK with checks on the one transaction, then we can in parallel make SNARKs. I mean, produce proofs for all transactions in a block. And then how we will link them? We will just publish a SNARK that checks that that we know the proofs for the SNARKs, who checks every pair of balances. And so if we start with n, if we have n transactions in the block, we give n SNARKs for all transactions in the block, and then we give another n divided by 2 proofs for every pair of these transactions, or this pair of just a minute.
I think it may be helpful if you maybe make some diagrams and maybe post on ETH research, because I think I have some difficulty following what set you're trying to make proofs on, what data is required to verify the proof, and what the guarantees are around that. I think it may be helpful to be able to clarify that in order to be able to reason about the design.
Okay. You may start with our proposal that was published in our domain by Alex Vlasov, and then I think we'll continue appending information to this proposal.
Just in case, the main idea was you can prove the individual state transition, and second, you can prove each pair, and then prove each pair of pairs. And this way you can...
That part is hard. That part is, there's no known way to do that part right now, as far as I can tell, in reasonable time.
Well, so far as Kostya tried to explain is that recursive SNARK construction is possible for this case.
The fact is, we have not checked recursive SNARKs yet, and there's no guarantee that we'll find the work.
Back of the napkin envelope on that one.
Yeah, I also seen in MIT's Madar's Wirza, I think in a month or so, he wanted to publish one more construction of recursive SNARKs. So at some point it will be curious to see, but so far, yeah, it's non-standard curve. It's not on a precompile, but in general, I don't know if such idea of recursive was a plasma constructions based on SNARKs
just
worth investigating. I mean, if,
yeah, it's worth investigating.
Just a quick remark. The only known construction of recursive SNARKs that is from the paper elliptic cycles on elliptic curves require two curves, and neither of them is in current standard.
Okay, yeah, maybe just do more research on this and maybe post on ETH research in terms of the aspects of the recursive.
And another problem that usual hashes that are used in maker proofs, that is, for example, SHA-2526 hashes, they are not suitable for SNARKs, because they lead to too many constraints, and all recent proposals, such as, for example, memes hashed, which are SNARK friendly, they are not studied well, and maybe they're not at all secure. For example, the authors of meme paper that they mostly concentrated on fields of
take a look more on stuff, and maybe there's going to be emerging research coming out in the next month or two, and maybe things can be updated then. But yeah, it definitely is an interesting area of research, and definitely as things update, could be an interesting model and construction to do that. I think having a good visibility on sort of what is being proved, I think could be very helpful, and it's a lot of good in-depth research. Yeah, thank you. But yeah, in any case, so how's everyone else? Like, is there other topics? I feel like we're a little bit short on time. Cool. I guess this is a good topic on the 4th, and I guess there's fun updates from everyone, from plasma debit all the way to explorations on SNARKs. Cool. Thanks everyone, and I guess we'll be seeing you next time.
Sounds good. See ya.
Bye. See you.
Bye bye.